Trigonometry, which comes from the Greek words trigonon, meaning triangle, and metron, measure, is the study of the relationship between sides and angles of triangles. It is applied in everyday life for things like navigation, to finding the height of an object, to calculating structural load.
In this scenario, for example, as Maya seems to have lost her oars, though luckily she was near a buoy which she's managed to tie her boat to, we might want to know how far Maya would have to swim to get back to land, or how high the cliff is, which she'd then have to climb to reach Fidel and James.
How can we work out the lengths of the sides of right-angled triangles without actually measuring them? The answer is trigonometry. When we say the horizontal line, we mean from the point of view of the observer.
For example, if we're looking down at Maya from where Fidel is sitting at the top of the cliff, the horizontal line would extend from where he is.
The line of sight extends from the observer to the object. If the angle formed between the observer's horizontal line and line of sight to an object is below the horizontal line, i.e., someone is looking down at something below them, as it does in this case, it is called an angle of depression.
However, if our observer were Maya looking towards Fidel, then the horizontal line would extend from her,
and we would say the observer's line of sight to an object is above the horizontal line. The angle created here would now be called an angle of elevation. Note that because the horizontal lines are parallel, the angle of elevation and the angle of depression will always be equal to each other. You may remember this from learning about parallel lines and the angles formed between them and a transversal. The angles of elevation and depression here are examples of alternate angles, and so their values will always be equal.
We know where Maya's angle of observation is on this triangle.
This is the angle we're interested in, either to find the size of it or, if it's a known angle, to use it to find another piece of information. When working with trigonometry, we need to start by naming a triangle's sides. The hypotenuse is the side directly opposite the right angle, and also the longest side of a triangle. The longest word for the longest side. The opposite side is an easy one. It's directly opposite the angle of observation. And the adjacent side? Adjacent means next to, and that's exactly what it is. The side next to the angle of observation. There are three main functions in trigonometry: sine, cosine, and tangent, each of which we can use to express a particular ratio of a side of a right-angled triangle.
Sine, written without the e for short, is the ratio between the opposite side and the hypotenuse.
Cosine, or cos, is the ratio between the adjacent side and the hypotenuse. And tangent, tan, the ratio between the opposite side and the adjacent side. An easy way to remember these ratios is SOHCAHTOA.
Sine equals O, the opposite, over H, the hypotenuse.
Cos equals A, the adjacent, over H, hypotenuse. And tan equals the opposite over the adjacent. Remember, before we can identify the opposite and adjacent sides, we first need an angle of observation or a reference angle. If you have problems remembering the ratios, perhaps you'll find this story useful. Many years ago, there was a family that lived along a river where they farmed and fished and lived a peaceful life. One of the sons was trying to learn his bow and arrow, without much success. He kicked out at the ground in frustration, but ended up stubbing his toe on a rock instead. His toe swelled up painfully. He rubbed it, wrapped it in leaves, and even tried ignoring it, but none of it helped. Finally, his mother lost her temper, pointed towards the river, and yelled, "Sock your toe!" So the boy went and sat by the river and soaked his toe in the cool water. He never got any better with his bow and arrow, but he never forgot what his mother said. SOHCAHTOA. Okay, onwards. Let's look at some sides and how they relate to the angle of observation. If you've been given the length of a side opposite angle theta and the length of the side adjacent to angle theta, how would you find the angle of observation? Think of SOHCAHTOA. We have the opposite, 4, and the adjacent, 3, so which can we use? We don't have a hypotenuse, so it can only be tan. Tan theta is equal to 4 over 3. To work out the value of theta, we need to isolate it on the left-hand side of the equation. Then we use the inverse of tan on a scientific calculator. You usually get to this by first pressing Shift or second function, then the tan button. Then insert either the fraction 4 over 3 or 4 divided by 3 in brackets. Then press equals and you will get the value for theta. So the angle of elevation we're looking for is 53.13 degrees. The values of trig functions for some angles in trigonometry have known ratios due to their properties. They are angles of 30 degrees, 45 degrees, and 60 degrees, and are called special angles. Have a look at this right-angled triangle with sides of 45 degrees. The two acute angles are equal, and therefore the two sides must be equal. This gives us a ratio which applies to any triangle that shares these same properties. So the trig ratios for 45 degrees will look like this. Quite cool, huh? The same principle applies to any right-angled triangle where the other angles are equal to 30 degrees and 60 degrees. This may not look so obvious at first glance, but if we do this, we see that what we're looking at is half of an equilateral triangle. So from these ratios for right-angled triangles with angles of 30 and 60 degrees, the trig ratios will look like this. Remember these angles. They'll save you a lot of time when working with trigonometry.
Back to Maya.
She's swum out from the boat and is now at the bottom of the cliff, her boat still out at sea. Fidel and James have finally noticed what has happened and are both at the edge of the cliff looking down at her. Fidel is curious about how high she has to climb up to reach them and decides to do some mental calculations. First, a line to represent his line of sight. Next, a horizontal line. The angle formed between this horizontal line and Fidel's line of sight is the angle of depression. And another horizontal line, this time from the boat to the bottom of the cliff. The angle from this horizontal line, looking up Fidel's line of sight, is the angle of elevation. There's now a right-angled triangle formed between the boat, the bottom of the cliff, and Fidel. Fidel knows the boat is floating 50 meters away from the base of the cliff, because he knows the buoy it's tied to is 50 meters away. It says so in the book he's been reading. He also knows that the angle of depression from him to the boat is 30 degrees because, well, just because he's Fidel. Remember, the angle of elevation and the angle of depression will always be equal to each other, so both of these angles are equal to 30 degrees. Fidel now has the value of the reference angle and the length of one side, the side adjacent to the reference angle, which is enough to find the height of the cliff, which is the length of the side opposite to the reference angle. From SOHCAHTOA, he knows to use the tan ratio and places the known values. Reference angle, 30 degrees. Adjacent side, 50 meters. To find the value for the opposite side, rearrange the equation so that opposite is by itself on one side. The answer? 28.87 meters. Easy.